name is Hannah Johnson.
And I'm Jenny Hippis.
And today we're doing the elevator project and find the acceleration of an elevator. This comes to play with Newton's second law, which states, the acceleration of an object field is directly proportional to the total force on the object and indirectly proportional to the mass of the object. Which that means heavier objects will require more force to be moved, and that means that the acceleration will change depending on the amount of mass that's going to be in the elevator. So here we go. Jenny and I believe that the deceleration or going down of the Jenny in the scale will have less acceleration or deceleration because gravity is helping pull it down than it will for the elevator and Jenny to go up and accelerate.
Currently, Hannah Johnson is drawing a force diagram of me standing in the elevator. The only two forces acting on me are gravity and normal, because we are only talking about the vertical direction. So we only have the two forces acting on me.
Go. So this is the total centimeters of one stair, 18.5 centimeters. And there are about 26 stairs from the first floor of the basement to middle floor of the school elevator. So if we multiply those together, we should get the total distance, which would be 481 centimeters. And to divide that by 100 so we can get it into meters, and it becomes 4.81 meters. So that's going to be Jenny. She's going to be our demonstrator. Her mass is 109.5. So now we are going to put her in the elevator and accelerate it downwards. And I will meet her down there.
Are you running down the stairs?
Yes, I am. Okay. Goodbye.
I'm not changing.
Well, I think you can't step on it.
Right now we are finding my weight in kilograms. I am 109.5 pounds, and we are converting that to kilograms. You take 109.5 divided by 4.53 times 4.53, sorry, Mr. U, and you will get the answer of 49.6 kilograms. Just like that. Right now we are finding my weight when the elevator is decelerating. I was 109 exactly when the elevator was decelerating, so once again we are multiplying that by 4.53, and you will get the answer of 49.37 kilograms. Now we are finding my weight when I am accelerating in kilograms. I was 111.5, and we are once again multiplying that by 4.53, and then we will get the answer of you forgot the 0.5.
Oh.
I apologize for Hannah's calculating skills. We get the answer of 50.50 kilograms. Right now I'm finding the time it takes to go up in the elevator. It is timing. I don't know if you can see that. When the elevator is fully stopped, on the way up I get 14.3 seconds. once again. When the elevator comes to a complete stop, I get 11.46 seconds.
Okay, so right now we are going to find the velocity of a stationary Jenny. To do that, we're going to take the distance over the time. Velocity would equal 0 because she was actually going nowhere because she was stationary and it took no time to be stationary. So in turn, acceleration equals velocity over time, which would actually be 0 as well. Now to find the velocity of accelerating Jenny, what you would do is take the velocity of the distance, which we found was 4.81 meters, over time, which was 11.4 about seconds.
Yeah.
And to do that, once we pull up a calculator, the velocity would be 4.81 divided by 11.4, 0.422 meters per second. To calculate and that into acceleration, you would take the velocity over time which would turn 0.037 meters per second squared. Okay, so now we're going to find the acceleration of Jenny going downwards. And I spelled down wrong, ignore that. Okay, so to find this, we're going to take velocity, which is distance over time, and our distance is going to be the same as the acceleration of Jenny going upward. So it is 4.81 meters, and this time it took her 14.3 seconds instead of 11.4. And if we solve this in a calculator, we are going to get 4.81 divided by 14.3, and our total velocity for acceleration of Jenny downward would be 0.336 meters per second. No.
No. Okay.
In order to use this to find acceleration, the acceleration equation is velocity over time. So this is actually going to be 0.336 meters per second over 14.3 seconds. So if we divide our answer by 14.3 seconds, we'll get 0.024 meters per second squared. Because Jenny is going downwards, it is considered deceleration, so this will actually be a negative. So to recap, stationary Jenny, the acceleration would be 0 because she wasn't moving at all, she's just stationary, there's no distance or time displacement. An accelerating Jenny upwards, acceleration became 0.037 meters per second squared. So that one was Jenny was on the basement floor of the school and going up. And the one we just found, which is acceleration Jenny downward, which can also be called deceleration, it was negative 0.024 meters per second squared, and it is a negative because she's going downwards or decelerating. And those are our answers.